Hi all, my name is Artem, Artem Brashkovich, and so I'm really happy to be here again. So that's probably my third presentation on that user group. Probably every year I present some new topics here, and thank you to having me again with my new topic, which is called one-click Sitecore deployment to Kubernetes. And basically, for maybe 2 or 3 last years, I took a lot of work related to the DevOps. I set up something around 10 Kubernetes environments, and every time it takes a lot of work, a lot of activities, a lot of time to configure everything and prepare. And not so long time ago, I just decided that I'm ready to invest my time to build something which can help me in the future to do that work more effectively, more quickly, and more probably flexible. So, and in this presentation, I'm going to share what I have actually done, and I will explain how we can use it, and probably maybe somebody will want to help and evolve that project with me together, some kind of community stuff. Let's move forward with the next slide. Why it is not switched? Okay, and just a few words about me. I have more than 12 years programming experience in general, and since April 2012, I work for Brimit and currently do the position of Sitecore solution architect or just solution architect. More than 11 years, I've been working with Sitecore and was awarded a Sitecore Technology MVP 4 times in a row. Okay, and just before we will go further for the next slides, I just need to quickly switch the screen to the new from the presentation to the Azure activities, because I just need to run the provisioning of the infrastructure, and because it takes time, and if we will do that just during the demo, we will not be able to see how it actually finished. I will just run provisioning now, and then we will talk a bit late during the presentation. We will talk in details what's happening there. Just a few words. Just before the presentation, I created pretty empty Kubernetes cluster and pretty empty Azure Key Vault instance. What I'm going to do, I'm just need to update a few variables in my repository, and actually in my DevOps tool, which is currently GitHub workflows. I have a few settings for my dev instance that I need to update. Okay, just let me copy it again. AKS demo settings. Okay, we have Azure Key Vault name. I need to update that one, and I also need to update. Okay, go to the resource. This is my cluster name. And I need to update the cluster name. So we will talk about the rest of the secrets a bit later. For now, we just need to update 2 of them, and probably that's it. I just need to run the pipeline, which is called provision infrastructure. So that's it for now. Let me just check. It is started. Okay, so we can switch to the presentation. Okay, and as probably you already understood, we will talk about the Kubernetes today. And I am almost sure that all of us somehow was show it and probably understand what is it. But I just want to say a few words, simple words. What is the Kubernetes, and how we are going to use it? In Kubernetes, Kubernetes is a powerful tool that automates and streamlines the management of your application. It ensures that the application the applications. Okay, it ensures that our application run reliably, scales them as it needed, and it keeps them resilient, allowing you to focus on your software and not on the infrastructure. So, in general, if we will read what is the Kubernetes, we also can find that it is like called like open source container orchestration platform that automates many of manual processes involved in the deploying, managing, and scaling the containerized applications. So actually, Kubernetes just orchestrate our containers, let's say our images that we run in Docker. So on the slide, I have put some diagram which is represent the pretty simple architecture of Kubernetes. It is for sure it is simplified, but it is explained which parts we have in our Kubernetes cluster. And each Kubernetes cluster have master node, which is used to run the Kubernetes itself, and it has at least 4 main services run there. The first one is scheduler, which is make sure that your application can be run on the certain node, and it actually do some work to choose the corresponding node for your application. Controllers make the work to run your application actually, and etcd storage is persistent, consistent, and highly available key value storage, which describes the current state of your application, of your cluster. If you change something, add new node, run new pod or something like that, everything is tracked and put to the etcd storage just to be able to rerun your cluster with the same workload. Part of the master node, we can see and we can run any number of user nodes which is served to run your applications. Each node, user node, also has at least 2 services, kubelet and the kube proxy. Kubelet is an agent which is used to communicate with a master node in your Kubernetes architecture, and it also do some health check, monitoring. It also register your node in the cluster, etc. Kube proxy represents a kind of network inside of the cluster. So, and the kube proxy is used to make it possible to communicate between applications, between nodes inside of the cluster. So the last thing here is the pods. Pods is the smallest entity in Kubernetes, and it is finally represent your application, or it can be any number of applications running in the Kubernetes, but each pod is represent some container, and container at the same time represent some image that we want to run there. But yeah, in general, Kubernetes does not seem easy, so it requires a lot of knowledge to understand how to work with it, how to run application there, how to troubleshoot something if something goes wrong, and for sure we need just understand why we want to use it, because sometimes it is not so easy. And the first thing that I should mention is scalability, because Kubernetes provide pretty good tools to scale your application automatically, so you don't need to think about that. So because you can just limit the number of, for example, nodes that you allow Kubernetes to create, but if if your application takes more resources that you expect in some certain things, because maybe some campaign was run and something like that, and Kubernetes track that your application require more resources, it will automatically create a new node and run your application there as well and start load balancing traffic between your applications. So high availability is something that Kubernetes do very well as well. So Kubernetes always track the state of your pods that you run, your application, let's say, and if something goes wrong with that, it will be rerun and tries to make it working again. We can easily move our application between different environments because originally Kubernetes always has the same infrastructure, and you can always be sure that your application, if you run it in one environment, it should be run in the another one. So the good advantage of Kubernetes also the resource efficiency, because Kubernetes provides resources dynamically based on what you need actually, and you actually pay only for the resources that you use. So it is sit close to the scalability, because when you need more resources, Kubernetes extends, run new pods. At the same time, if you don't need these resources, the Kubernetes will reduce them, and you will not pay more. So when we deploy, for example, new application, new version of application, Kubernetes Kubernetes at least has the option run the new one in a parallel with the existing one. When the visitors still go to the old one, new instance of your application will be created, and only when Kubernetes will make sure that it works and healthy, the traffic will be switched from the old one to the new one, and old application will be terminated. So declarative configuration means that we describe using actually Kubernetes manifest. We describe what we want to reach as a result of execution of deployment, and kind of describe desired state, and Kubernetes do everything to reach that part. And in a proper configured development process for Kubernetes, it just take one click to deploy new code to the environment, which provide for developers, which makes it easy for developers, and they can not think about the infrastructure. They just can focus on the code. So, and the good news here that Sitecore officially support deployments to the Kubernetes, and it was introduced probably around 2 years ago, or maybe less. I don't remember exactly. But if you will download the guide and go through all of them, all of its steps, you will get the following infrastructure running in Kubernetes. Again, it is a bit simplified, but I put here the most important part of the architecture. So we have the Azure Kubernetes Services, or AKS, which is Sitecore used to run own environments. And we can see that we have ingress controller, Nginx ingress controller, which is serve as a proxy server. And based on the rules, it route traffic, for example, for editor to the CM server, for site visitor to the CD server, in case of non-headless application. So we have external services, which is SQL, Solr, and Redis, and it is highly recommended to use use them as external services for production, but for non-production instances, we also have an option to run it in the cluster itself. So then you can save your money, because you will not pay for some cloud resources, for SQL Server, for Solr at least. They are the most expensive. But for the non-production, you can run it all together in the cluster. It requires more resources allocated for Kubernetes cluster, but it is even cheaper than run them and use them as a cloud service. Once it is Azure architecture, and we can AKS uses Azure Active Directory to allow us as a users, as a developers, to communicate with the clusters through some CLI tools, and we can manage our clusters using some PowerShell or any other shell. It makes sense to mention it that by default, if you will follow just the documentation, you will use Sitecore container registry. It is like a storage for somebody who don't know. It is like a storage for for the images, Docker images that we can pull image from. And by default, all manifests, Kubernetes manifest provided by Sitecore uses their own images. So this is working environment. This is the environment which will work, but that's a bit far from the real environment that we usually use with our our customers. And at least if you want to, for example, install PowerShell, Sitecore PowerShell, if you want to install SXA or some other Sitecore modules, we have to build our custom images on top of the existing one. So because when we want to install new modules, we need to load some assemblies to the container, etc. So then, in case we want to reach that, we have to introduce our own CI/CD process, which will build images for us. And actually, we have to push our images. We have to store them somewhere. But once Sitecore uses own container registry, we cannot push there anything, which is clear and obvious. But in case we want to use our own, we have to use our own container registry. So it can be Azure Container Registry, or as in my case, in my example, I use GitHub Container Registry. So then we as I said before, so this infrastructure reproduce non-headless application because we don't have a rendering host here, for example, or something. We don't have any other tools to render our content, our JavaScript application. And I don't know what is your experience, but in my experience, the most projects that we got for last years, they was headless, and it makes sense just to focus to develop them. In case of my project, I mean that DevOps project, let's say, and I want to introduce here the rendering host, which will be also run in Kubernetes. And another option that also will work fine is a Versal, where we can run our application. And in case of Versal, it will be communicate with our cluster through Ingress as well and get data from the CD server. And if we will run our rendering host inside of the cluster, again, it will be communicate with CD or CM server as we decided, but that will be like internal communication, so no traffic goes outside in terms of the communication between rendering host and CD server. So these diagrams represent more or less work scenario, work and architecture that we can develop for our customers, and in that case, it will work better than original one. How we can deploy something to the Kubernetes, or how it actually works. And everything which we run in Kubernetes should be described with some Kubernetes manifests. And for example, you can see that we have a kind property in each Kubernetes, in each YAML files. Actually, this is the YAML files. And kind is specify the type of object that we are going to create, run in Kubernetes. And so the service account is used to authenticate the Kubernetes or some workload that we run in Kubernetes with some external services or something like that. For example, we have a pod which has the image already, and we have another pod here with different image, but that's pretty simple Kubernetes manifest. So usually it takes like 100 or even more lines with a lot of different environment variables, etc. And the main problem here that we have to specify the values. We can move them to the secrets or something like that, but anyway, we have to specify that values before we want to load or deploy that part or that kind of that service account to the Kubernetes. And this was the problem, and probably this is the reason why in the Helm charts come to our lives. And let's see what is it and how it can help us. Helm in general, Helm is a tool that help us define, install, and upgrade applications running in Kubernetes. At its most basic, Helm is a templating engine that creates Kubernetes manifests. So as a result, when we run, when Helm built the package or chart, finally it becomes a Kubernetes manifest, but it can be done in a bit more flexible way. Helm is represent at least two main parts. This is template, which is called chart. And for example, it looks like that. So the same service account, but instead of values, we use variables. And values for that variables are described in the values config files. It is represented by the YAML files as well with the YAML structure. And we can define values already in the config files. And when we will run Helm chart installation, we can specify any number of values files, so early configs, and each next value config will override values from previous one. So it works like Docker Compose files. When you have one basic one, you have base compose file, and then you override or extend it with the particular YAML or Docker Compose file. The same here. You have one base values, and then if you want to specify values for different environments, for example, you can add any number of values, value configs files, and set environment specific values there in the simplest way. As well as we can specify the value for variables in the values files. We also can specify the values on the runtime. Actually, the Helm upgrade command is used to deploy some chart to the Kubernetes, and here we also can override the values that we put in our values files. So like client ID, for example, in this example, the client ID comes from some, it can come from secret, for example, or in my case, it is come from the previous job that create something in Azure and provide this client ID. And then on the deployment time, I'm just set it to my Helm chart. So in case of using simple and the regular Kubernetes manifest, it was not impossible to do so because it should be already prepared and saved. So, and only one case that I can use to provide it dynamically, just to replace values in already created YAML files with some PowerShell, and I have to do that on the CI/CD pipelines. So, what is the benefits to use Helm? And first of all, it is reduced complexity of deployments. it provides a bit more complexity on the initial state when you have to build your Helm charts, because, for example, for Sitecore, we didn't have Helm charts, but actually what we are talking now, so I have already prepared it for us, and we have like more reproducible deployments and results, because so you can deploy every time the same, and it is ability to leverage Kubernetes with single CLI command. So the deployment to Kubernetes just looks like on the previous state, we just have one command that we use. We just specify which shard to deploy, and that's it. So better scalability, because we can manage the number of replicas, for example, for our pods, and we can use values for that. So, and we can specify it on the deployment time. Again, we can reuse the Helm charts across multiple environments, and more streamlined CI/CD pipelines. Also a good advantage of that. And when we deploy some Kubernetes chart to the Helm chart to the Kubernetes, it is always create a new release, and each release has a number, and you can always roll back to any previous releases you want, and which makes pretty easy to manage your versioning. In case of any required rollbacks, you can easily do that. And again, good news for developers. They don't need to contact with construct with individual YAML files. They can do just their development work. Don't need to manage Kubernetes manifest files. Let's compare two approaches that can be used within the Kubernetes deployment. Actually, this is very simple. There is deployment without Helm charts and deployments with Helm charts. So we can see that without Helm charts, we have our Kubernetes YAML files, YAML manifest files prepared, and only one way how we can make it more flexible, we need to override them, maybe just replace some tokens inside of that YAML files on the deployment time, which is I was actually did before I started to use Helm charts. I was right that the manifest file using some tokens inside and just replace them on the just before I was going to deploy it to the Kubernetes instance. In the case of deployments with Helm chart, we can specify at least we have common Helm charts, which means that if you need to use some tool which is already developed by another teams, or even this is kind of, for example, the SQL Server, we already have the Helm chart published for SQL Server. It was published a lot of time ago, so we can just reference it, and you don't need to specify your own YAML files, YAML manifest for that. So some work can be automated, some work can be done just referencing some already exists Helm charts and just configure it to use. Then you specify the values for different environments and just install it to corresponding cluster or environment. Okay. Once we already know that we can use Helm, let's see the next diagram that I prepared for you, and what's different here. And this is actually what we need to try to achieve in general when we build at least UAT production environments. There is a Helm update command put here. So because on our CI/CD process, on the CI, we will just build images and push them to the container registry. And when we will be ready to deploy it, we just do Helm update command. We just run Helm update command and send it to the Kubernetes. As a result, Kubernetes itself will be pull latest, or even not latest. It will pull the image of version that you specify in your Helm chart. Okay, so it is a good practice to use some Azure front door or another firewalls before the traffic goes to our Kubernetes cluster. So it is also as addition, it is always better to run our cluster within some static IP address, which we associated with our Nginx ingress controller, because if you don't use the static IP address and you will stop your cluster and then run it again, for some reason, I don't know why, you will lose your IP address. So the traffic will not go to the cluster before you will not update at least Azure front door, or for example, if you don't have Azure front door and just use your DNS server to point traffic from some custom domain to the cluster, you will have to update your DNS records in case of you don't use static IP address. Okay, so we will focus on the rendering host running inside of Kubernetes because for me it was most usual case. So then when you run your environment, you have to use some SSL TLS certificates. And if you will follow just a guide provided by Sitecore, you will create your own self-signet certificate, or maybe you have some certificate that you bought for your domain. You have to put it to the secrets, you have to track when it updates, when it expires, and which kind of potentially be a problem in case of some human mistakes and something like that. So Kubernetes usually use Cert Manager to manage certificates. You just actually use, in my case, in particular case, I use the Cloudflare to sign my domains with some certificate. So I can use any number of subdomains. The certificate for them will be automatically created and signed by Cert Manager using Cloudflare as a provider. So another thing that also important is to keep our secrets in the Azure Key Vault and not in the files as it's described originally by Kubernetes secrets. I will show you a bit later about that, but we have Kubernetes also have secret stored CSI driver to pull secrets from Azure Key Vault as a secrets in Kubernetes. So you manage all your secrets inside of the Azure Key Vault, and they will automatically pulled by cluster using that driver. And for production, it is also very important to have some monitoring tools to understand the health of your cluster, of resourcing, and something like that. So this is the original. This is like ideal world of the Kubernetes environment, the minimum ideal. So I think we can introduce much more tools that we can run, but I think that's pretty much production version of the Kubernetes cluster. But in my demo, we will not use that much of resources and the tools used. Actually, we will build something like something what you see on the diagram. We will not use Kubernetes or Azure front door because I have my own domain that I bought in the Cloudflare. They provide some firewall and all traffic goes through them. Also, we will not use some monitoring tools. And as it is not a production, of course, I run all that services, external services within the cluster itself. So that's pretty it. So this is what we are going to reach. And on that diagram, you can see the main, the most important duty we can address with the project that I've done. I cannot say that this is software, so this is not a tool. So this is a lot of tools actually. First of all, we can provision and configure in Azure infrastructure, so we don't need to do anything manually. and except of creating the cluster itself and secrets. It also can be automated with, for example, Terraform, which I probably will do in the future. If we will have time, I will extend, and I'm going to evolve the project. So, and I think we will reduce that manual steps as well. So we can improve in certificate management, improve in Kubernetes secrets management, etc. And we will simplify and optimize our CI/CD processes and approaching, and also I will show how we can sync our content when we work with the Kubernetes environments, just to avoid that like also almost manual step that was I used as before. And just try to speed up because we have some time limit and I still have a lot of to show. Some pre-requirements for using the workflows and CI/CD pipelines that I am going to show. Of course, we have to have Azure subscription as Azure Service Group created. So we have to create Azure Service Principal that we will use to allow GitHub to communicate with Azure. So we need some key vault created, we need AKS cluster created. Of course, as we have, if you want to use the full power of GitHub workflows, it is better to have some professional account. But in case of some public repositories, you can even use the standard one. It will also allow you to use multi-stage environments, environments and architecture. And in my case, I also need the Cloudflare account because it is used as a provider to sign the certificate. So for sure, everybody can configure that part as they want, but it's just some Helm chart need to be updated for sure. And I think we are ready to do some demo of what is done. I very hope that provisioning is done. Okay, yes. And we can see that it was done successfully. First of all, let's see what was created. Where is my PowerShell? Okay. Once we created a new cluster, we need to log in to the cluster and still use the same resource group that I was used before. I'm just cleaning it up and create a new cluster. So let me make our current newly created cluster as a context cluster. And now we can use the tool called like Kub9s, which is provide very good, pretty good tool to work with the Kubernetes. You don't need to run the commands every time manually. You can just switch between different type of resources. So we can see that with the pipeline that we run at the beginning of the presentation, we have installed the Kubernetes cluster, we have installed the certification manager, we have installed TCI secret store provider for Azure. So, which means that if we will, let's switch to the default namespace, we actually have to, okay. And if we will, for example, look, come on, secret, we can see that we already have some secret pulled, and which is good. Okay, now the next step that we have to do in case of our deployment over Sitecore, when we run the infrastructure provisioning, it was create some. Actually, which work was done? Okay, sorry, let me just start do something. I need copy the new static IP address which was created and update my DNS records, because if I will not done it, it probably will not be updated in time. Let me just quickly update it. Okay, so DNS record is updated, and another important thing that we need to do, actually, before I will run the deployment of Sitecore itself, I need to update the secrets. But once it is currently created key vault, I have to do some role assignment for myself to be able to read the secrets. Come on. Why it becomes slow every time it is the most important to be fast. Okay. Come on. That's not a good time. Uh, this is something wrong with Edge itself, as usual. Okay, let's give him a few minutes to load, and I will show you. I will show you. Okay. Mhm. When you will download the Sitecore Kubernetes manifest, it will looks like, for example, on the screen. So you have a list of YAML files that you execute one by one. For example, first of all, you need to run the external services. Then you need manually update all secrets in the secrets folder, because originally it is store secrets as a files, and for sure it's not a good idea, because it is not secure, because you will push your Kubernetes configuration to the some repositories. You need to somehow update it. It is why it is important to use Azure secrets to store that sensitive information, as well as originally the certificate stored as a files in the file system, which is not good idea as well. So to apply all of them takes a lot of time. If you will go through the Sitecore guide, you need to do that, and you need to restore, replace secrets, etc. So it takes first time it takes days for sure. For me, for the next time, it is not take so much time, but it is a lot of manual work that you have to do before you can run it. And what is the difference? With what we have now? For example, we have Sitecore Helm charts repository that actually used to create and build our Helm charts. Let me check. Okay. Um, okay. It is become live again, and I need quickly do some changes that allow us to continue deployment. Okay, I need give me some Okay, and at my laptop to be able to read secrets. So now we can see a list of secrets that was created by my scripts. And only one secret that we have to update is the Sitecore license, because it is not a good idea to store it in the pipeline as well. New version, secret, create. That's it. So now we can run the second part of deployment, which deploys Sitecore itself. Okay, and let's continue with the Helm charts. So I have introduced a list of Helm charts because it was not possible to put everything in one, and it is not required because when we want just provisioning some basic data, basic tools to our cluster, for example, I used the cluster init Helm chart, which is referencing actually CSI secret store provider and the Ingress Nginx controller that will be installed. Also, it is installing some basic stuff like config map with some basic configuration put here. Okay, this is the config map. This is pretty basic parameters that are not really required to be stored in the secret and can be just stored in some secret file or in some config file. We have a service account. Oh, come on. We have a service account here, which I was put to the screenshot in my presentation, and we have the secret specification because the secret provider just read the secrets as a list, and then we just merge them to the more readable and structured secrets architecture in Kubernetes. So basically, when we install that chart, we get ingress controller installed, we have secrets work done, we have everything which is required to work our cluster with that external services. Next Helm chart that we install in is a certificate manager. It also points in some external Helm chart, and it installs some cluster issuer and certificate that is used to sign the certificates inside of our cluster. And what we only do, we just override some values of the chart that we download from the chart repository, and especially of this cert manager. So we specify the namespace where we want to install. We specify the cluster resources namespace. You can actually specify any values that chart has. And this is the next chart that we install. So then we have a Sitecore dev chart, which is represent the cumulative chart with subcharts that are used to run a SQL Server, Redis, and Solr inside of our instances. And actually, in the pipeline that I will show in a few minutes, you can choose if you want to install them or not. So actually, you can maybe if you don't need them, you want to install them as you want to use the SQL and Solr server as a external services. You just don't need to choose it the tick checkbox, and it will not be installed. Then we have Sitecore XM1 init Helm chart, which will do the initial work for us, and actually it initiate databases and Solr indexes. Of course, we have two different value files. In one file, we just specified some global settings for the chart, and in the second one, which is related to the Sitecore 10.3, which specify the images of our init jobs. I use my own container registry because I had to extend default Sitecore init images with the tools like SXA, PowerShell, and JSS because we run actually the headless application. We have separate charts for each role, and for example, for CM, we have deployment, we have ingress specification, we have some item sync job, and a lot of etc. stuff that it's pretty the same as Sitecore provides for us in the when we just download it from the Sitecore site. But in that case, it is everything put to the one file and part of that put to the ingress configuration. In my case, it is separated because it can be installed separately. We can install only CM server, we can install only CD or rendering, or we have Sitecore XM, which is actually pointing all previous Helm charts. They are all looks to the my Helm chart repository, which is public, and just specifies values for that. For each role, we just specify the host names and images, which are also pushed to the my container registry because, again, I extended with some additional modules that I wanted to run for this demo. Only one unusual image here is Sitecore items, and it is used to item sync because when you use the Kubernetes, and you use Sitecore serialization, you need to implement some approach, some process that will allow you to sync the content, and usually you just need to run some CLI commands to run the sync. Basically, in my case, I just built additional image with own Docker file which copy all content items, which is serialized already in your solution, to this image. It also has some PowerShell scripts that are used when you run the image in your Kubernetes. It will sync the item that was placed in the container. So you just deploy it within the CM server. Item sync job will wait until the CM server is run and healthy. Once it is healthy, it will execute some command which will sync content that was pushed to the image from your solution. Usually I do the same version of the sync, the item image, and the same version of the custom image with custom code, and which always goes in a pair. So for the rendering image, for the rendering pod and rendering host, we also have some Helm chart that run Next.js application. But it is a bit easier to understand which images we have because we have a second public repository called Sitecore images. And here you can find the example of Docker files for each role, at least. For example, for CM role, we just do a copy of files from the images of modules to the main one. There is no any custom logic. There is only what I just done. I'm just copy and install Sitecore modules to my images. And if you look to the rendering image, we can see that I use the latest version of SXA Start Kit, which is used actually by XM Cloud to run their application. It supports SXA, and I've just downloaded and run it in Kubernetes, and I was able to build my site just using the SXA components introduced in the GSS. And for the items, I simulate some solution, which includes just the simple items of website. to be able to initiate some website and show you a hello world page. So let's see, deployment still goes. Let's have a look what we have actually deployed already. All good. I think just yeah, so items was serialized. It is almost done. I think we will be able already to reach CTM. It is currently deployed Sitecore instance, which should be already available because it waits while the item sync job will down, but it has some timeout, sleep time at the end. It will be once it will be done. I think it will be successfully finished as well. Okay, password already saved because I use the same domain. Just a few minutes and we will be finished. Okay, let's do publish because we only sync the items, but we haven't published them. And actually, the last repository that I want to talk about this is Sitecore DevOps. It has some short introduction of the secrets that you need to add to your repository where you're going to use the workflows. It is explained how you can create the service principle that allow you to communicate between GitHub and Azure, and all over and both, not both, there are more than both two workflows are introduced here. You have provisioning infrastructure, which we was run first, and if you will look at it, okay, it is done. We can see that there is a lot of PowerShell put here, starting from establishing connection between Key Vault, because it is kind of a lot of requirements need to be implemented in Azure to allow Kubernetes communicate with Key Vault. So some workload identities need to be added, some permissions need to be added and allocated, and a lot of stuff done by PowerShell. Then some reused workflow is used to populate secrets. And if you will look to the this pipeline, there is a list of secrets that are created in Key Vault. They have some default values that you have to update in case of using it in your real project. And let's back to the populate infrastructure. We populate secrets, and once the secrets are populated, we install the cluster init Helm chart, which I was showing you before, and set some arguments here. This is the arguments that dynamically get from the previous steps, like provisioning the Azure infrastructure, etc. And a part of the some always required secrets. Basically, I have implemented some action that install the Helm chart. We just need to specify the repository URL. We just need to specify the cluster or the Helm chart name. It will be installed to our cluster. Then we install the cert manager. Then we set up the dependencies if it was selected, and that's probably and we have to install the init images and execute the init jobs. So this is what actually provisioning infrastructure pipeline do. And if you want to execute it, you just, of course, you have to copy or do the fork and run it in your repository. But so there is a checkbox that you can choose if you want to run SQL Solr and Redis services in your Kubernetes cluster, and then you can also choose the environment that I'm going to deploy to. So that's it. here, let's see, publish is finished, and then sc and this is our hello world page. So, but this is a completely headless application, and it is done only with the SXA components, which is already provided with SXA starter kit from Sitecore. So that's quickly it, and let's back to the presentation again. There is just 2 slides left here. So there is links to the repositories and container registry and Helm chart repository that you actually can use if you want to use the Helm charts to deploy your Sitecore instances. And that's it. Thank you for your attention. Hope it was not so boring.